So expectation doesn't just have to be wheels. We can apply it to everyday probability situations as well. So for example, let's say we flip a coin. And if it lands on heads, we're going to win $7. If it lands on tails, we're going to lose $2. And the question is, what is the expected win or loss? And we're going to define X as $1. So that'll be my definition of X. And we're going to make our table. XPX and our XPX. Now sometimes it probably would not be necessary in this problem, but sometimes it's useful to add an actual column right at the beginning. And the column that's sometimes useful to add at the beginning is the result column. And that's more of a label. It's not really a mathematical necessity. So what are the results when we flip a coin? So the result is either it's going to land on heads, or it's going to land on tails. And then there's a value X to a certain result. And that's the one that we're going to actually use in the calculations. So the value X of the coin landing on heads is 7. The value X of the coin landing on tails is 2. The probability, of course, is 50-50. So this value is 3.5. This value is 1. Oop, I made a mistake. It's actually lose $2. So that's going to be negative $2, which is going to be negative $1. Because the way I had it before was if you were winning 7 or winning 2. And then we take the sum of these guys, and the sum of these guys is 2.5. So what that means is that for this game over here, where with these rules, we expect to win $2.50. Now, we're not going to win $2.50. We're either going to win $3.50 or lose $1. I mean, we're either going to win 7. Actually, sorry, we're going to win 7 or lose 2. But we expect to win $250. So should you play this game? Absolutely. Okay, we're going to flip a coin twice. So we'll do the same thing. We'll kind of make our XPX table. And we'll throw on an R column before for results. Might be a useful thing to do. So we're going to do our X there. So we're going to flip 2 coins. What are the possible results? So we could either land, the results are either 2 tails, or 2 heads, or it could be head tail or tail head. And what are the values of these things? For 2 tails, the value is 17. For 2 heads, the value is 11. For 1 of each, the value is 3. The probability is going to be 1 out of 4, 1 out of 4. It's often useful to keep the probabilities in fractions, but you don't have to. You could always turn into decimals. So this is going to become 17 over 4, 11 over 4, and 3 over 4, which, when we add them up, is going to be 31 over 4, which I'll do it now. So 31 divided by 4 is 7.75. So the expectation from this game is $7.75. So if we play this game, where X is the amount won, we expect to win $7.75. Okay. Roll 2 6-sided dice, and then we're going to add them up. If the sum is 10, we win $90. Otherwise, we're going to lose $10. Should you play? So we're going to figure out the expected value of this thing. So we're going to have our X and our X of P of X. And I'm going to put a results column. And remember, the results column is actually optional, but I don't know why you would not do it. So for the results column, what can we get? So in theory, we could go through all the possible results. So one way of doing it, we could say, well, so let's say this is the result, and this is the x. You could say, okay, if the result is 2, you win 0. You lose $10. If the result is 3, you lose $10. If the result is 4, you lose $10. If the result is 5, you lose $10. If the result is 6, you lose $10. But that's kind of a waste. We don't actually have to do all that. What we're going to do instead is we're going to say the results are either that you roll a 10, you roll a 10, or you don't roll a 10. And if you roll a 10, that's going to be worth 90. And if you don't roll a 10, that's going to be worth negative 10. Now the probabilities, do I still have that beautiful dice chart? I do not. So the probability of rolling a 10, if you remember, is actually going to be 3 out of 36. And the probability of not rolling one is going to be everything else. So it's going to be 33 out of 36. So this becomes, our XP of x is going to be 270 over 36. And I could have reduced these, but you don't have to. In this case, I could have reduced them to 12, so it may have been useful, but you only have to reduce at the end of a problem, not in the middle. So the sum, 270 and negative 330, is going to be minus 60 over 36. And we can divide it by, both of them by 12. And it's going to give us negative 5 over 3, which is negative 1.67 or so. If it's money, you should round to the nearest penny. So I guess that's 100th. So what's going to happen? So should you play? So what we expect, our expectation from this game is negative 1.67. So we expect to lose $1.67 every time we play. We're probably going to lose $10, but we expect to lose $1.67. Should we play? Well, no. Why would I play a game that I expect to lose? It doesn't make sense. What is a fair game? So, like, what would make a game fair? So losing money obviously is not great, and winning money is not really fair. I mean, it's fair to me. So if I was going to say a fair game is going to be one, like if the question was, is the game fair, then you would want an expectation of 0. That means you don't expect to win money, and you don't expect to lose money. And that's fair.